129. We're learning about how the brain has two hemispheres.
Are they the right and left hemisphere?
That is correct, sir. The brain is actually divided into two hemispheres, the left hemisphere and the right hemisphere. If you take them apart and look at their different parts, they each have the same parts. Each of them has a midbrain and a brainstem and a cerebrum and a cerebellum, and they do basically the same sorts of things. One reason that there's two halves is they operate in redundancy. Have you ever heard that word, redundancy?
Mm-hmm.
That means if one part breaks, the other part can take over. As a matter of fact, there are people who have had some diseased brains or problems with their brains. There's one child I know that had the whole right hemisphere of the cerebrum removed. And they lived just fine.
Hold on. Can their head just cave in right there? Or?
Yeah, I think they put, their skull there. So your skull is hard. And I think it fills up with something when you take that much out. I don't know what it is. Fluid or something. But you can live without a whole half of your brain. The other half will take over and do all the functions for you. And even if you take out huge chunks of one half, you don't lose memories like you would think. You think you take out half the brain, you lose half your memory, but that doesn't happen like that. So we still don't know exactly how memory works. But there is redundancy among the two halves. But there is also differences in the two halves. For most people, the left hemisphere is where things associated with language and math occur. Language and mathematics are usually found in the left hemisphere of the brain. Working problems, thinking about language. If you have a damage to Broca's area, which is in the left part of the frontal lobe, you will have trouble with language. You can't process language, and you can't understand what people are saying. Actually, wait, I got that wrong. Broca's area, you can't speak the language. Wernicke's area is toward the back. You can't understand the language. But the left seems to do with language and math, and the right seems to do with spatial orientation and art. Things like that seem to be more in the right hemisphere. When I say spatial orientation, I mean, are you the kind of person that gets lost all the time very easily? You may not be good in the right, you may not be as strong in the right half of your brain as you are in the left. Usually people who are strong in the right half of their brain are very artistic and can understand shapes and directions and things like that a lot better. So it's odd that the brain sometimes has its left and right half division, asymmetry, which, some tasks, some people are more left brain and some people are more right brain. I said before that control of the muscles of the left side of the body happen in the right side of the brain, and control of the muscles in the right half of the body happen in the left side of the brain. So sometimes people have a stroke where they lose blood supply to one part of the brain, and they often will lose the ability to move their muscles just on one half of their body. And sometimes, that can happen in various ways. I remember going to a ball game with my dad, who's a doctor, and he saw a lady, and the right side of her mouth, she was talking, and she wasn't moving this side, and she was only moving the other side. And this was all like droopy, and her eye was droopy. And I was just a little kid, and I was like, Dad, what's wrong with that lady? And he said, well, she probably had a stroke, and she can't move the right side, any of her muscles on the right side. And I thought, that's pretty cool that you can tell that just from stuff you know. Huh.
Does that happen to people if you just chop off half their brain?
That's a good question. Seems like it would, wouldn't it? Yeah. Because the right cerebrum controls the muscles, but perhaps some way, if you do it early enough, the other half can take over for it. The person who had that brain surgery had their cerebrum removed as a kid, and perhaps the other side was able to take over for it. It's a good question. You can see even vision. Everything in the left half of your visual field goes to the right occipital lobe, and everything in the right half of your visual field goes to the left occipital lobe. Yeah?
Is there any reason why it works like that?
I don't know. Probably. There's probably a good reason, but I don't know what that reason is. Why would it switch over? I don't know. This brings up a pretty cool operations that people have had done. One of the problems a lot of people have are seizures. Have you ever heard of a seizure? It's when part of the brain is, the neurons keep firing and they won't stop firing. Sometimes people have what's called epileptic seizures, where the part of the brain that's firing signals is part that controls their muscle movements. And so they start shaking like this, and they can't stop. And that part of the brain is just firing signal after signal for no reason. And they can't stop moving their muscles, and they shake. And one way to control epileptic seizures, they've found, is to cut the corpus callosum. Now, the corpus callosum is this big band of tissue right here. And it's basically a transverse tissue. It runs from one side of the brain to the other. And it's just wiring. It's just those axons that run from the cells over here across to the cells over here. And scientists have figured out that if you cut the corpus callosum, that'll stop the seizures. So a lot of people have these operations, and why that works, I don't know either. There's a lot about the brain I don't know. So there's a lot to know. But if you cut the corpus callosum, you'll stop the seizures. But interestingly, if you cut the corpus callosum, you prevent the two sides of the brain from communicating with each other. And the two sides of the brain become unaware of what the other half is doing. And it leads to some interesting psychological experiments. The Division of Hemispheres. Let me show you one of the experiments that it goes over in your reading that you're doing this weekend. What they'll do is they'll set a person in a chair and have them stare at a screen. And then they'll flash a picture on the screen. Now the picture only stays up there for like a second. And the person is told to look right in the very center. And so here's what the picture they're shown looks like. It's a half picture, a boy and a man. Now remember, the left side of the brain sees the boy, and the right side of the brain sees the man. You see what I'm saying? Are y'all with me so far? Now if you put a pen in the hand of the person looking at this picture and you put it in his right hand, what side of the brain controls your right hand movements?
Your left side.
Your left side of the brain controls your right hand movements. And so if you said, draw a picture of what you see with your right hand, the person will draw the man's face. Or if you were to say, point to the person you saw, if the person points with their left arm, wait a second, did I get this right?
Oh, the right side saw the guy. Not the left side.
Oh yeah, I screwed that up. Yeah, the right side saw the man, the left side saw the boy. So if you said, draw with your right hand what you saw, the left side saw the boy. So the left side, the right hand is going to draw the boy. I screwed that up when I was explaining it. Does that make sense? If you said point to what you saw, and the person pointed with their left hand, they point to the man's face. Because the right side of the brain saw the man. And the right side of the brain controls the left half of the body. So the right side of the brain has the person pointing at the man with his left hand. But if you told the person to point with their right hand, what would they point to?
Boy.
The boy.
And did they explain to them, hey, you know, you're pointing at two different people?
They did afterward. Watch this little video showing these experiments. They're really cool. They're called split brain behavioral experiments.
Our left hemisphere and right hemisphere now are working independent of each other, but you don't notice it. Now you just kind of adapt to it. It doesn't. You don't have any feeling different than it did before.
7 years ago, Joe had brain surgery to allay the effects of severe epilepsy. His surgeon cut the nerve fibers connecting his left hemisphere with his right. While the operation was a complete success, Joe's unusual case offers an extraordinary insight into the machinery of mind. This fiber system, the Corpus Callosum, is located midway between the two hemispheres. When it was surgically severed in Joe's brain, the transmission of information between the two hemispheres was halted. Michael Gazanica.
What we can do is play tricks by putting information into his disconnected, mute, non-talking right hemisphere and watch it produce behaviors. And out of that, we can really see that there is, in fact, a reason to believe that there's all kinds of complex processes going on outside of his conscious awareness of his left half brain. Joe, I'm going to show you some things. I just want you to tell me what you see. And here we go. You ready? Look right at the dot.
Okay.
Right. Okay, you ready? Right at the dot.
Great.
Good. When Joe focuses on a point, right at the dot, everything to the right of the point goes to his left brain, the dominant hemisphere for language and speech. Right at the dot. So we can see here that when we flash a word or a picture, Joe is easily able to name it. There we go.
See it.
Close your...
Now remember, the left hemisphere is where language is coordinated. So you can say, you know, words and read words because it's going to your left hemisphere.
Rise and let your left hand do a little work here. Okay, what do you got there? Okay, very good. Now, when a word or a picture falls to the left of a fixation point, that information goes to his disconnected right half brain. And as we can see here, Joe is unable to name it. Joe is able to draw the picture with his left hand, the left hand getting its major control from the right half brain. Good job.
Okay.
What do you see?
Wheel on one side, I don't know where it's on.
So even though he can't name it, his left hand is able to draw out the picture of the stimulus of the picture or word that we presented to his right half brain. What did you see? So just close your eyes and draw with your left hand. Just let it go. That's nice. What's that?
Saw.
Yeah. What did you see?
Hammer.
What did you draw that for?
I don't know.
What we have with Joe is a dramatic example of a neurologic case that really allows you this window into the non-conscious and how powerful non-conscious processes are at influencing our conscious self, our personal self. What Joe and patients like him, and there are many of them, teaches us is that the mind is made up of a constellation of independent, semi-independent agents, and that these agents, these processes can carry on a vast number of activities outside of our conscious awareness. Even though that goes on, there's some final stage or some final system, which I happen to think is in the left hemisphere, that pulls all of this information together into a theory. It has to generate a theory to explain all of these independent elements. And so, and that theory becomes our particular theory of ourself and of the world.
So he's not consciously aware that he saw that saw. But the right side saw it and can draw it, even though he's not consciously aware of it. Isn't that strange? It's crazy. Cool. And so that's what...
Wait, so if his right side only deals with like art and stuff like that, how is his right side able to understand like what he's saying, then draw it?
It's not able to understand, it's able to see it and draw it. But it can't say what it is or understand what it is, it can copy it.
When he says close your eyes and draw with your left hand, how does his other side of the brain know to tell the other brain to draw? They can't.
It doesn't.
It's not. The right side of the brain controls the left hand. The right side's doing all the work. It's drawing with the left hand, see? So they get into that more in this video that we're continuing, that we started last time. They get into just that. So we're continuing here. Make sure you read the last section of chapter 4.
A very different one than we saw just 4 months earlier.